Good morning, students. I welcome you all to the new academic year. Hope you are all safe by God's grace. As we start our science lessons, first let us start with the physics lesson, Laws of Motion. In the previous classes, you must have learnt about various types of motions like linear motion, circular motion, oscillatory motion, and so on. In this lesson, let us investigate the cause of motion. Now I would like to ask you a few questions. How a car at rest starts moving, or a moving car comes to rest? Now tell me, children, how a body moving slowly increases its speed, or a high speed object suddenly slows down, or an object moving in one direction changing in another direction. One answer to all the above questions is nothing but force. So what is force? Force is nothing but push or pull of an object. Now let us look at the concepts proposed by the scientist Galileo. Galileo proposed the following concepts about force, motion, and inertia of bodies. According to him, all earthly bodies, either they will be in the state of rest or in the state of uniform motion. A body in motion will continue to be in the same state of motion as long as no external forces apply. The body cannot change its state by itself, and that is called as inertia. When dropped from a height in vacuum, the bodies of different size, shape and mass, they fall at the same rate and reach the ground at the same time. Now let's do an activity. Take a glass tumbler and place a small cardboard as shown in the figure. Now keep a coin at the center of the cardboard. Then flick the cardboard quickly. Now what do you observe? You can see that the cardboard falls off the ground and the coin falls into the glass tumbler. Now this is due to the coin at rest continues to be in the state of rest. This is called as inertia. The inertia is nothing but the inherent property of a body to resist any change in its state of rest or the state of uniform motion unless it is influenced upon by an external unbalanced force. There are three types of inertia: inertia of motion, inertia of rest, and inertia of direction. Now let's first look at inertia of rest. For example, when a train at rest suddenly starts, what happened to the passengers? The passengers sitting inside, they tends to fall backward. This is because the lower part of the body starts moving with the train while the upper part tends to be at rest due to inertial at rest. The resistance of the body to change its state of rest is called as inertia of rest. Next, let us look at the inertia of motion. When a moving bus suddenly stops, the passengers sitting inside, they fall forward. This is because the lower part of the body comes to rest while the upper part of the body tends to remain in motion. So this is due to the inertia of motion. So the resistance of the body to change its state of motion is called as inertia of motion. Now finally, the inertia of direction. When you make a sharp turn while driving a car, you always tend to lean sideways. So this is nothing but the inertia of direction. So the inertia of direction is nothing but the tendency of a body to oppose any change in its direction of motion is known as the inertia of direction. Now let me ask you a question. If you threw a big stone at the wall wouldn't get damaged. But if someone fires a shot at the wall, it could make a hole at the wall. So we can say the impact produced by the object depends on both the mass and velocity of the object. So the product of the mass and the velocity is nothing but called as the momentum. Newton gave the definition for momentum, and momentum is denoted by the letter P, which is equal to mass into velocity, where the SI unit of mass is kilogram and for velocity it is meter per second. So the momentum The SI unit of momentum is kilogram meter per second. Now let us learn about Newton's first law of motion. This law states that every body continues to be in its state of rest or a state of uniform motion along a straight line unless it is acted upon by some external force. That is, if a body is at rest, it continues to be at rest. If it is in motion, it continues to be in motion unless an external force acts on it. So Newton's law of motion gives the definition of force as well as inertia. Now let us see the definition of force. It produces or tries to produce the motion of a static body. It stops or tries to stop a moving body. Or it changes or tries to change the direction of motion of a moving body. So force has both magnitude and direction, and so it is a vector quantity. Next, let us learn about like and unlike parallel forces. Forces are classified according to the direction. Now let's look at the like parallel forces. When two or more forces whose line of action acting in the same direction, they are called as like parallel forces. Now here these two are the same direction. So I can say that when two forces are of equal magnitude or unequal magnitude but they are parallel to each other, they are called as like parallel forces. Next, let's just learn about unlike parallel forces. Here the forces whose line of action are parallel to each other but they are acting in the opposite direction. So the forces are acting in the opposite direction, they are called as unlike parallel forces. Next, let us learn about resultant force. In the first case, now both the forces are acting in the same direction. So the net force will be F1 plus F2. In the second case, two parallel forces are acting in the opposite direction. They are unequal. So the net force will be, if F1 is greater, it will be F1 minus F2. If F2 is greater, it will be F2 minus F1. And the net force will be along the direction of the greater force. And in the third case, two forces are acting parallel to each other and they are equal. So the net force will be, since F1 and F2 are equal, it will be F1 minus F2. Since F1 is equal to F2, so it will be equal to 0. So in case 2, the resultant forces are unequal to 0, so they are called as unbalanced force. And here in the case 3, the resultant force is equal to 0, so they are called as balanced forces. Next, let us learn about the rotating effect of force. Let us consider this door. This end of the door is fixed. Now when we want to close the door, when we apply the force over here, we won't be able to close the door. But when we apply the force at a distance far away from the edge, we can easily close the door. The door can be easily closed or open when you apply the force at a point far away from the fixed edge. This turning effect of the applied force is more when the distance between the fixed edge and the point of application of force is more. The door is attached to a fixed edge. The axis of the fixed edge about which the door is rotated is called as axis of rotation. Next, let us learn about moment of force. The rotating or turning effect of a force about a fixed point or fixed axis is called moment of force. So if the turning effect is about the fixed axis, that is called as the moment of force. And about the fixed point, let us consider a rod fixed at a point A, and when we apply a force F, it can be rotated about the fixed point. Let D be the distance from the fixed point. Then the moment of force or the torque about the point is equal to force into the perpendicular distance. The unit for force is Newton and for distance is meter. So the SI unit for torque is Newton meter, and torque is a vector quantity since it has both magnitude and direction. Let us learn about what is couple. Two equal and unlike parallel forces applied simultaneously at two distinct points constitute a couple. Consider a rod and the forces are acting like this. Both the forces are parallel to each other, but their line of action do not coincide. So they do not produce any translatory motion. The couple produces rotating effect which is called as moment of couple. Moment of couple is denoted by the letter M, which is equal to force into the perpendicular distance between the two forces. Here the force between the two forces be denoted by the letter S. So F into S. So the unit for the moment of couple will be Newton into meter. So it is Nm. So unit for moment of couple is Newton meter. Now the examples of moment of couple will be turning a cap, winding or unwinding a screw. So the forces may be acting in the opposite direction, or spinning a top. So here again the forces will be acting in the opposite direction. So it constitutes a couple. So the rotating effect of a couple is called as moment of couple. Next, let us learn about the applications of torque. First, let us see about the gears. A gear is a circular wheel with teeth around its rim. It helps to change the speed of rotation of a wheel by changing the torque and helps to transmit the power. Next application of torque is seesaw. Most of you have played on the seesaw. Since there is a difference in the weight of the person sitting on it, the heavier person lifts the lighter person. When the heavier person comes closer to the fulcrum, less amount of torque acts on it, so this enables the lighter person to lift the heavier person. The last application of torque is steering wheel. A small steering wheel enables you to turn a car easily by transferring the torque to the wheels with less effort. Now let's recap what we studied before. The first one we studied about inertia, the inherent property of a body to resist any change in its state of rest or the state of uniform motion unless influenced by an external unbalanced force is known as inertia. Then we studied about momentum. The product of mass and velocity of a moving body gives the magnitude of linear momentum. What is Newton's first law of motion? Newton's first law states every body continues to be in its state of rest or uniform motion along a straight line unless it is acted upon by some external force. Then we learned about what is moment of force or torque. Rotating or turning effect of a force about a fixed point or fixed axis is called moment of force. And finally we learned about what is couple. Two equal and unlike parallel forces applied simultaneously at two distinct points constitute a couple. Thank you children. Stay home, stay safe.